Welcome to Do the Math America. I am Charlene, the Math Shaman.
The introduction to fractions is covered in the beginning algebra book from pages 59 to 62. Please look at the description box below this video for a link to the PDF file of this textbook. Fractions are commonly used in our daily life. 1. A fraction is used to represent each part of a whole number that is divided into smaller and equal parts. This bar represents one whole thing. If I were to divide it into smaller and equal parts, I could make fractions. I could show 1/5 by dividing that bar into 5 equal parts and highlighting one section. To show 2/5, I would divide that same bar into 5 equal parts and highlight 2 sections. To show 2/7, I would draw that same bar, divide it into 7 equal parts, and highlight 2 sections. The same idea works for any fraction you would want to represent. You draw out a bar. The lower number, the denominator, tells you how many sections to divide the bar into, and the top number, the numerator, tells you how many of those sections to highlight. So for 5/8, we draw out a bar with 8 equal sections, and we highlight 5 of those sections. For the fraction 15/16, we draw out a bar, divide it into 16 equal sections, and highlight 15 of those sections. A fraction is also used to represent a division of two whole numbers. 2 and 5 are whole numbers. 2 divided by 5 is written as 2/5 or 2/5 with a slanted fraction bar. And as mentioned earlier, the top number is the numerator and the bottom number is the denominator, and the bar in the middle is called the fraction bar. You can think of the fraction 1/3 as 1 divided by 3. The fraction 4/7 is 4 divided by 7. 8 divided by 9 can be thought of as the fraction 8/9. The denominator can never equal 0 because you can't divide a number by 0. It is recognized as undefined. For example, the fraction 3/0 is undefined. Equivalent fractions are fractions that have the same value. So here we have one whole apple. If I cut it in half, 2 equal parts, I have 2 halves of an apple. And here I have 1/2 of an apple. Now, if I take those 2 halves of the same apple and cut those in equal halves, now I have 4/4 of an apple. 1/2 of an apple is equal to 2/4 or 2/4 of an apple, and those are equivalent fractions. So here we have 1/5, or one whole thing divided into 5 equal parts. And I emphasize one of those equal parts to show the fraction 1/5. Now suppose I take that same whole thing and divide it into 10 equal parts. If I emphasize 2 of those 10 equal parts, then I show the fraction 2/10. 2/10 is an equal fraction or equivalent fraction to 1/5. That same thing or bar divided into 15 equal parts, with 3 of those equal parts emphasized or highlighted, shows the fraction 3/15, which is also equivalent to 1/5 and 2/10. Another example with the fraction 3/4 or 3/4. So I have one bar divided into 4 equal parts, highlighting 3 of those equal parts. That same bar divided into 8 equal parts, with 6 of those sections highlighted, shows the fraction 6/8, which is equivalent to 3/4. Now that same bar, broken down into 16 equal parts, with 12 of those parts highlighted, shows the fraction 12/16, which is equivalent to 3/4 and 6/8. The fraction 15/20 is also equivalent to 3/4, 6/8, and 12/16. To check if two fractions are equivalent or equal, we may use the following ways. Two fractions are equal if their cross products are equal. So we take the fraction 1/5 and we check to see if it's equivalent to 2/10. We perform a cross product. That is, we take the denominator of one fraction multiplied by the numerator of the opposing fraction. And if those products are equal, then the fractions are equal. So 10 times 1, is that equal to 5 times 2? 10 does equal to 10, so therefore 1/5 is equal to 2/10. Is 1/7 equal to 3/22? So we take the cross products of 1/7 and 3/22. Does 7 times 3 equal 22 times 1? 22 times 1 equals 22, and 7 times 3, or 3 times 7, equals 21. So 22 does not equal 21, therefore 1/7 does not equal 3/22. Does 2/3 equal 6/9? We take the cross products. Does 3 times 6 equal 2 times 9? 2 times 9 equals 18. 3 times 6 also equals 18. Therefore, 2/3 is equivalent to 6/9. The other way to check if fractions are equivalent is we multiply or divide both the numerator and denominator by the same number. So here we have the fraction 2/5. If we multiply both the numerator by 2 and the denominator by 2, we get the fraction 4/10. 4/10 is equivalent to 2/5. And think of the 2 that you're multiplying above the fraction bar and the 2 below the fraction bar as 2 divided by 2, which equals 1. So any number multiplied by 1 equals itself. So even though 4/10 has a different name than 2/5, it is equal or equivalent. The same principle applies in reverse. So if you take the fraction 4/10 and you divide both the numerator by 2 and the denominator by 2, you get the fraction 2/5, which is equivalent to 4/10. And again, you can think of the 2 that you are dividing by above the fraction bar and the 2 you are dividing by below the fraction bar as 2 divided by 2, which equals 1. So any number divided by 1 equals itself. So 4/10 divided by 1 equals itself, or 4/10. And that's why 4/10 and 2/5 are equal, even though they have different names. So far, we have looked at proper fractions, where the numerator is less than the denominator, such as 1/2, 2/3, 4/5, etc. Improper fraction is where the numerator is greater than or equal to the denominator, such as 2 wholes, 3 halves, 5/4, 1 whole, 2/2, 5/1, etc. So here we have 2 whole apples, and if we divide or cut each of those apples into 3 equal parts, then we have 6/3 of apples. And if we eat one of those thirds, we now have 5/3 of apples. So just to reiterate, proper fractions are those in which the numerator is smaller than the denominator. So 1/2, 4/9, 7/18, 3/4, etc. are proper fractions. Improper fractions are those in which the numerator is larger than the denominator, like 2 wholes, 9/4, 18/7, 4/3, etc. Mixed numbers are numbers in which there is a whole number with a fraction, such as 2.5, 3 4/7, 5 7/19, 5 1/4. To change an improper fraction to an equal mixed number, we divide the numerator by the denominator. So here we take the improper fraction, 7/4. We convert it to a mixed number by dividing 4 into 7, or 7 divided by 4. So 4 goes into 7 one time. 4 times 1 equals 4. We subtract 7 minus 4 equals 3. We take the remainder, 3, and that becomes the numerator of the new fraction, and 4, the divisor, becomes the denominator. 7 divided by 4 equals 1 3/4. Next, we convert the improper fraction, 18/5, to a mixed number. 5 goes into 18 3 times. 5 times 3 is 15. 18 minus 15 is 3. The remainder, 3, becomes the numerator, and the divisor, 5, is the denominator. So 18/5 is 3 3/5. The improper fraction, 9/2, converted to a mixed number. We divide 2 into 9, or 9 divided by 2. So 2 goes into 9 4 times. 2 times 4 equals 8. 9 minus 8 equals 1. The remainder, 1, becomes the numerator, and 2, the divisor, is the denominator. So 9/2 equals 4 1/2. The improper fraction, 32/15, is 32 divided by 15. So 15 goes into 32 2 times. 15 times 2 equals 30. 32 minus 30 equals 2. The remainder, 2, is the numerator, and 15, the divisor, is the denominator. 32/15 is 2 2/15. To change a mixed number to an equal improper fraction, we multiply the whole number by the denominator and then add the numerator. The result is the numerator of the improper fraction. The denominator remains the same. So for the mixed number, 3 1/3, we multiply the denominator, 3, by 3, the whole number, which gives you 9. You add 1 from the numerator to equal 10. 10/3 is the improper fraction. To convert the mixed number, 4 3/4, to an improper fraction, we multiply the denominator, 4, by 4, the whole number, to get 16. We add 3 from the numerator to get 19. So 19 becomes the numerator, and 4 is the denominator. Is 19/4. To change the number 5 7/25 to an improper fraction, we multiply 25, the denominator, by 5, the whole number, and then we add 7 to get the numerator. So 25 times 5 equals 125. 125 plus 7 equals 132. 132/25 is the improper fraction. To double check our calculations, we can go in reverse. 132/25 is 132 divided by 25. 25 goes into 132 5 times. 25 times 5 is 125. 132 minus 125 is 7. 7 is the numerator, and 25 is the denominator. So we can confirm that 5 7/25 is 132/25. A proper fraction is in lowest terms when the numerator and the denominator have no common factor other than 1. To simplify a proper fraction in lowest terms, we divide both the numerator and the denominator by the same non-zero number, the greatest common factor, GCF. To write the fraction 18/24 in its simplest form, we first do the prime factorization of 18. So 18 is an even number, it's divisible by 2. 2 goes into 18 9 times, and 9 is divisible by 3. 3 goes into 9 3 times. So now we have the prime factors of 18. They are 2 times 3 times 3. The prime factorization for 24, 2 goes into 24 because it's an even number. It goes in 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. So the prime factors of 24 are 2 times 2 times 2 times 3. Now we cancel the like factors from both the numerator and denominator. 2 divided by 2 equals 1, and 3 divided by 3 equals 1. What remains is 3 in the numerator and 2 times 2, or 4, in the denominator. So 18/24 in the simplest form is 3/4. To write 13/39 in its simplest form, we do prime factorization of the numerator and of the denominator. 13 itself is a prime number, so it cannot be reduced. 39, however, is divisible by 3. So 3 goes into 39 13 times, and 13 is a prime. So the prime factors of 39 are 3 times 13. Now we can cancel like factors from the numerator and denominator. 13 divided by 13 is 1. So 1 is the numerator, and 3, which remains in the denominator, is the denominator. 13/39 simplifies to 1/3. To simplify the fraction 25/125, we do the prime factorization of both the numerator and the denominator. 5 goes into 25 5 times. The prime factors of 25 are 5 times 5. Now we prime factorize 125, which is also divisible by 5. So 5 goes into 12 2 times. 5 times 2 is 10. 12 minus 10 is 2. 5 goes into 25 5 times. And 5 goes into 25 5 times. So 125 factors out to 5 times 5 times 5. Now we cancel like terms from numerator to denominator. So the numerator 5s cancel with the 2 5s in the denominator to equal 1 in the numerator and 5 in the denominator. 25/125 is 1/5 in its simplest form. Let's simplify the fraction 45/108. First, we get the prime factorization of 45. 3 goes into 45 15 times. And 3 goes into 15 5 times. So the prime factors of 45 are 3 times 3 times 5. Now I will do the prime factorization of 108. If you are uncertain of how the shortcut division works, please watch my video, Lesson 22 on prime factorization. The prime factors of 108 are 2 times 2 times 3 times 3 times 3. Now we cancel like terms between the numerator and the denominator. So the 2 3's in the numerator cancel with the 2 3's in the denominator. What remains is 5 in the numerator and 2 times 2 times 3, which is 12 in the denominator. So 45/108 simplifies to 5/12. And you can see how much easier it is to envision 5/12 compared to 45/108. A mixed number is in simplest form when its fractional part is in lowest terms. When we write a fraction for an answer, we always write it in simplest form. Conventionally, the simplest form of a fraction can be 1, a proper fraction in lowest terms, or 2, a mixed number when its fractional part is in lowest terms. To write 5 and 4/8 in simplest form, we need to make sure that the fraction 4/8 is written in its simplest form. Break out 4 and 8 in their prime factors. The prime factors of 4 are 2 times 2, and the prime factors of 8 are 2 times 2 times 2. And now we cancel like factors. The 2's in the numerator cancel with the 2's in the denominator. So now we have just 1 in the numerator and 2 in the denominator, which makes the fraction 1/2. 4/8 simplifies to 1/2. So 5 and 4/8 simplifies to 5 and 1/2. 5 and 9/8 is both a mixed number and an improper fraction. So to write that number in its simplest form, we first work with 9/8. So 9/8 is 9 divided by 8. 8 goes into 9 once. 8 times 1 is 8. 9 minus 8 is 1. 1 becomes the numerator, and 8, the divisor, is the denominator. So 9/8 is 1 and 1/8. Now we add 1 and 1/8 to 5. So the two whole numbers add together to make 6. The simplest form of 5 and 9/8 is 6 and 1/8. Okay, let's write 72/24 in its simplest form. So we start by writing 72 divided by 24. And 24 goes into 72 how many times? And we write out some multiples of 24. So 24 times 1 is 24, 24 times 2 is 48, and 24 times 3 is 72. So 72 over 24 is 3. 72/24 equals 3. The other way we could have done this problem would be to find the prime factorizations of each number. So the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. And the prime factorization of 24 is 2 times 2 times 2 times 3. Now we cancel like factors. So the 2's in the numerator cancel with the 2's in the denominator, and the 3 in the numerator cancel with the 3 in the denominator, and you just have a 3 left in the numerator. 72/24 equals 3. To write 121/13 in its simplest form, we find that it doesn't really help to do the prime factorization. 121 factors out to be 11 times 11, and 13 is already a prime number, so that won't simplify. And so there's no common factors in the numerator and denominator that we can cancel. So we treat 121/13 as a division problem, 121 divided by 13. And we quickly compute some multiples of 13 on the side. And we find that 13 goes into 121 9 times. 13 times 9 equals 117. 121 minus 117 is 4. The remainder 4 becomes the numerator, and 13, the divisor, is the denominator. So 121/13 simplifies to 9 and 4/13. And we can double check our calculations to see if it's correct by converting 9 and 4/13 into its improper fraction. So 13 times 9 equals 117 plus 4, the numerator, makes 121 over 13. So it is correct. Now we look at 49 21s, or 49 over 21, which is 49 divided by 21. We can do the prime factorization of each number. So 49 breaks down to 7 times 7, and 21 breaks down to 3 times 7. We cancel like factors from the numerator to the denominators, leaving us 7 thirds. 7 divided by 3, and 3 goes into 7 2 times. 3 times 2 is 6. 7 minus 6 equals 1. 1 becomes the numerator, and 3 from the divisor is the denominator. So 7 thirds simplifies to 2 and 1/3. 49 21 simplifies to 2 and 1/3. And we can see it's much easier to envision this mixed number than the original improper fraction. To write 117 ninths in its simplest form, we write the prime factorization for 117, and that works out to be 3 times 3 times 13. And the prime factorization for 9 is 3 times 3. So we cancel like factors from numerator to denominator. Both the 3's cancel out, leaving us just 13 in the numerator. So 117 ninths simplifies to 13. To compare fractions, we express each fraction with the least common denominator, LCD. LCD is the least common multiple, or lowest common multiple, of the denominators. You can watch my video, lesson 23, on greatest common factor and least common multiple. To compare fractions, we must write them in equivalent fractions with common denominators. To compare the fractions 2/3 and 3/5, we must look at their denominators, 3 and 5. The common denominator of 3 and 5 would be 15. We just simply multiply those denominators together. We take 2/3 and multiply both the numerator and the denominator by 5 to get the equivalent fraction 10/15. Next, we work with the fraction 3/5 by multiplying both the numerator and the denominator by 3 to get 9/15. Now we are able to compare 2/3 and 3/5. 2/3, which we have renamed 10/15, is greater than 3/5, which we have renamed 9/15. So therefore, and those triangle dots mean therefore, 2/3 is greater than 3/5. Now let's compare 5/18 and 9/13. Since these fractions have different denominators, we can't make the comparison until we write them in equivalent fractions with the same denominator. So we take 5/8 and multiply both the numerator and the denominator by 13. And we do those calculations on the side away from our original problem, so we don't get our computations all messed up. And we find that 5 times 13 is 65, which is the new numerator, and 8 times 13 is 104, the new denominator. Next, we multiply 9/13, both the numerator and the denominator, by 8 from the denominator of the other fraction. So 9 times 8 is 72, and 13 times 8 is 104. Since the denominators are now the same, we can compare those fractions. 65 over 104 is less than 72 over 104. Therefore, 5/8 is less than 9/13. Next, we compare 4/5 and 11/12. So once again, we need to rewrite those fractions in equivalent fractions with common denominators. We take the fraction 4/5 and multiply both the numerator and the denominator by 12, the denominator from the other fraction. We get 48/60. Next, we take 11/12 and multiply both the numerator and denominator by 5, the denominator from the other fraction. And we end up with an equivalent fraction, 55/60. Now we can compare those two fractions because they have the same denominator, and 48/60 is less than 55/60. Therefore, 4/5 is less than 11/12. Now let's compare 10/63 or 10 over 63 and 3/56 or 3 over 56. A simple way to get the common denominator is simply to multiply each fraction with the denominator of the opposing fraction. So for 10/63, we multiply both the numerator and the denominator by 56. And we end up with the equivalent fraction of 560 over 3,528. Next, we take the fraction 3/56 or 3 over 56 and multiply both the numerator and denominator by 63, taken from the denominator of the opposing fraction. And we end up with the fraction 189 over 3,528. Now we can compare the two fractions because they have the same denominator. 560 over 3,528 is greater than 189 over 3,528. Therefore, 10/63 or 10 over 63 is greater than 3 over 56. And while I hope this video has been helpful for you, the only way you can really learn fractions is by doing lots of practice problems on your own. And here are plenty of practice problems in this textbook for you to work through. Please take the time to do as many problems as you need in order to gain mastery of fractions. And also, be sure to check your work with the answers in the back of the book to make sure you did the problems correctly.
If you find my video helpful, please give me a thumbs up. Subscribe to my channel for more videos on math lessons, and please share this channel with anyone you know who wants to learn math. Thank you for joining me at Do the Math America.